Welcome to the second part of microcanonical ensemble. Earlier we have studied about, or I have given you a basic introduction about microcanonical ensemble. In this section we will find out the thermodynamics of systems in microcanonical ensemble. Basically our aim is to find out thermodynamics of any system, systems like a collection of atoms, molecules, electrons, photons, etc. Therefore, we have a very good equation, bridging equation, S is equal to k log omega. From that equation, S is equal to k log omega, how to find omega we will deal with in the next section. In this section, if omega is known to you, how will you find the thermodynamics of the system? Therefore, if S is known, how will you find pressure, energy, entropy, susceptibility, etc. That is the aim of this section. Okay. Therefore, you have S is equal to k log omega, which is the Boltzmann's equation. Now, from the first law of thermodynamics, you have delta Q, or if you give heat to a system, which I will represent that by delta Q, then that for that system there will be a change in internal energy and there will be an external work done, and the work done can be in different forms. It can be used to increase the volume, it can be used to remove the number of particles, it can be used to magnetize a system or demagnetize a system. Different types of work done will be here. There will be definitely there will be a change in internal energy, and that is given by dE. Here we will represent that energy by E. Therefore, the change in internal energy is dE. Therefore, delta Q is the heat given to a system, and D is the change in internal energy, and if there is a change in volume, the work done will be P dV. If there is a change in number of particles, the work done will be mu dN, where mu is the chemical potential. Mu is given by dW by dN. Mu is dW by dN, the work done to remove the particles. But when you do work, the number of particles will be decreasing from the system, but when you do work, the volume of the system will be increasing. Therefore, I will give plus sign for P dV and minus sign for mu dN. Therefore, when you substitute the Clausius equation for entropy, that is TdS is equal to delta Q, or ds is equal to delta Q is equal to ds divided by T. Therefore, I will get ds is equal to delta Q is equal to TdS. Therefore, TdS is equal to dE plus PdV minus mu dN. This equation is known as the first law of thermodynamics. In your degree or undergraduate or your pre-degree classes, you will not be taking into consideration that mu dN factor. But in statistical mechanics, you will be interested in finding out chemical potential, susceptibility, etc. And hence, there will be always a third term in your first law of thermodynamics. Therefore, now you have TdS equal to dE plus PdV minus mu dN. Now, how will you find this different thermodynamic properties? For example, if I want to find out temperature, then you have TdS is equal to dE plus PdV minus mu dN. Therefore, if I fix our volume and number of particles as constants and then take a partial derivative, when I fix volume and number of particles, then whatever derivative I take will be a partial derivative, not the exact derivative. Therefore, dou S by dou E with a V and N constants, that will be giving you the temperature. For example, if your omega is equal to e raised to 3n by 2 V raised to n, then your S will be equal to nk log, that n will be coming as a common factor here. Therefore, that n I can take outside. S is equal to nk log e raised to 3 by 2 into V. Therefore, if I e raised to 3 by 2 into V, therefore, if I take a partial derivative of S with respect to E, I will be able to get, if I am taking a partial derivative, what I can do is, therefore, you are given omega is equal to e raised to 3n by 2. This is an example, V raised to n. Therefore, you have S is equal to k log omega, and this becomes k log e. I will take e raised to 3 by 2 V whole raised to n. Therefore, x raised to y is y log x. Therefore, it becomes n k log e raised to 3 by 2 into V. This is my entropy. Now, my aim is to find out temperature or which in turn I will get energy. Therefore, I have to take a partial derivative of entropy with respect to E, keeping V and N as constant. Therefore, this N is constant, this V is constant. Therefore, I will simply rewrite this expression as Nk log E raised to 3 by 2, log A into B is log A plus log B. Therefore, plus Nk log V. Therefore, if I take a partial derivative of this term, it will be 0. Therefore, I am not bothered about the second term. Therefore, this equation, as far as I am concerned, where I am interested in finding out 1 by temperature, only this expression need to be partial derivative. We have to take the partial derivative. Therefore, this will be 3 by 2 Nk log E. I am not bothered about this constant, because when I take the partial derivative of the constant, it will be equal to 0. Therefore, then if I take this is my S now. If my S is partially derivative, if I find the partial derivative of this one, I have 3 by 2 Nk and log E. If when I take derivative, it becomes E. Cross multiplying, I will get E is equal to 3 by 2 Nkt. This is how from omega you will be finding your entropy. This is how you can find entropy if omega is given to you. In the next section, I will be telling you how to find omega, but here I will be taking some omega, because our aim is to find out to work out some UGC or gate or just problems. Therefore, I will be taking omega, and if omega is given to me, how will I find this my thermodynamic property? Okay. Therefore, that is the first problem. Now, let us find out, okay, sorry, I will find out pressure also. Therefore, if I want pressure, TdS is equal to d plus PdV minus mu dN. If I am interested in finding out pressure, same omega, I will take same omega. Now, S is equal to Nk log E raised to 3 by 2 into V. Now, this dou S by dou B keeping E and N constant. Therefore, this N is constant, K is constant, E is constant. This equation simply changes to Nk log V only, plus some constants, Therefore, dou S by dou V will become Nk logarithm of V. If you take a derivative, will become Nk by V. Therefore, dou S by dou V, which is P by T, will be equal to Nk divided by V, which on cross multiplying I will get that as PV is equal to Nkt. Now, if I am interested in finding out chemical potential, I will take another example, E raised to 3n and V raised to n. Omega is equal to E raised to 3n, not by 2. If I take 2, I will have to do a lot of work. Therefore, I am just avoiding that. Therefore, E raised to 3n, V raised to n. And it must be given, because I am going to find out dou S by dou n, and I have to check whether my E and V are number dependent. Therefore, I will take E is equal to, instead of 3 by 2 Nkt, I will take E is equal to 3 Nkt. There are a large number of systems where energy is not equal to 3 by 2 Nkt, it can be 3 Nkt. Therefore, if I have that 3 Nkt, if I substitute that, therefore, my equation will become Nk log E cube into V, N is taken here, that E I have to take that as 3 Nkt. And in that case only I am interested in finding out dou S by dou n only. Therefore, whatever is that n dependence, that I have to take, and rewriting, putting that E in this equation and taking out that n dependence only, removing all other dependence, I can write my equation as S is equal to Nk log C plus 3 n log n. Now, after simplifying, I will get my chemical potential. I can simplify and get the chemical potential. This is how you will be able to find out your thermodynamics. My basic aim is how to find the thermodynamics, and if I know omega, I can find entropy, and from entropy, by using first law of thermodynamics, I will be able to get all the thermodynamic properties. Therefore, this part of finding thermodynamic properties has been asked for UGC examination many times. How to find? You will be given some omega, and they will be asked to find out different thermodynamic properties. Okay, some problems we will find out. This was This was a question that was previously asked. Therefore, you are given E is equal to Bs cube V divided by Vn. B is a constant, S is entropy, V is number, volume, and N is number. You are asked to find out the internal energy of the system is given by, you are asked to find out what is the temperature of the system. Temperature of the system. Bs cube Vn. Bs cube Vn. Therefore, E is equal to Bs cube divided by Vn. You are asked to find out what is the temperature. Therefore, 1 by T is equal to dou S by dou E, keeping V and N as constants. Dou S by dou E, dou S by dou E. Therefore, what I will do is I will take the inverse of this one. Therefore, I can say that T is equal to dou E by dou S, keeping V and N as constant. Now, E is this equation. Therefore, whatever the variable is only S. Therefore, I can keep my B and V N as constants. Then I can take a derivative of S cube, which will be equal to 3 S square. Therefore, your answer of temperature will be equal to 3B S square Vn. 3B S square Vn. This is your answer. 3B S square Vn. Okay. Next is you are given a paramagnetic system consisting of n spin half particles placed in an external magnetic field. It is found that in that external magnetic field n by 2 spins are more in the upward direction and n by 2 spins are aligned in the anti-parallel direction, anti-parallel to the magnetic field. What is the statistical entropy of the system? Even though the problem is given in a very complicated way, this problem is very simple. You have only n by 2 particles in the up direction, or you have two types of states, one in the up direction and the second one is total n by 2 plus n by 2 will be giving you n number of particles. Therefore, you are given n number of particles and the number of states possible will be 2. Therefore, it is very simple, omega is always 2 raised to n. Therefore, S is equal to k log omega means S is equal to k log 2 raised to n. Therefore, answer, there is no need to go on working out all these things. The answer is 2 n k log 2. The answer will be 2 n k, sorry, this is 2 raised to n. Therefore, n k log 2, n k log 2. That is k log 2 raised to n, which will be equal to n k log 2. Next is you are given entropy of the system. Entropy is n k log A V e raised to 3 by 2 n raised to 5 by 2, where E is the total energy, A is a constant, K is the Boltzmann constant. You are asked to find out what is the chemical potential. Chemical potential is mu by T is equal to minus dou S by dou n, dou S by dou n. Therefore, I will put this A V e raised to 3 by 2, I can put this A V, I will put this C is equal to A V e raised to 3 by 2. I can write C is equal to A V e raised to 3 by 2. Therefore, my S now will become n k log C, because I am taking a partial derivative. Therefore, my A and V are V and E are constants. Therefore, this will become n raised to 5 by 2. This I can rewrite as n k log C minus n k log n raised to 5 by 2, which I can once again write as n k log C, n k log C s minus 5 by 2 n k log n. This is my entropy. Now, the equation is very simple, n k log C minus n k log 5 by 2, this is 5 by 2 n k log n. Therefore, I am asked to find out what is dou S by dou n. Dou S by dou n is, first part only one n is there, therefore, k log C minus the second part is n contains n is there in two places. Therefore, I will take this 5 minus 5 by 2 k outside, and then inside first I take this derivative n log n. Therefore, it is log n log n minus n log n by n, that is 1. Therefore, my equation will be k log c, that is my c, a v e raised to 3 by 2, k log a v e raised to 3 by 2 minus 5 by 2 k log n minus 1, minus of minus will become plus, minus of minus will become plus, but your mu by t, dou s by dou n is equal to minus mu by t. Therefore, there will be a negative sign once again coming, that negative sign here will be there. K is a common factor everywhere, therefore, it becomes minus kt, and you have log c is there, that is a v e raised to 5 by 2, and you have this log n minus n log n into 5 by 2 is outside, therefore, it once again becomes log n raised to 5 by 2, log n raised to 5 by 2, then there is minus 5 by 2 plus 5 by 2 kt, therefore, your equation will be minus kt log a v raised to 3 by 2 divided by n raised to 5 by 2, minus sign, minus of minus becomes plus 5 by 2. This is one of the example, a very good example for finding out the thermodynamics of a given system using microcanonical ensemble. Yes, this is the way in which I had done that. Now, you are given S is equal to 4 by 3 sigma into V raised to 1 by 4 U raised to 3 by 4, where sigma is a constant, P is equal to. Therefore, I am asked to find out what is pressure. Therefore, I have this pressure P by T is equal to dou S by dou V, keeping E and N constants. E and N constant. Therefore, I have to take a derivative with respect to volume only. Derivative with respect to volume only. But if I take a derivative with respect to volume, I can change this to a constant C. Therefore, I have this 4 by 3 sigma, U raised to 3 by 4, and I have to take that, there is no logarithm here. V raised to 1 by 4, if I take a derivative, I will get 1 by 4 V raised to minus 3 by 4. This is my P by T. But this is not the equation that is answer that you have. Your answer is related with the energy, internal energy U. Therefore, what I have to do is I have to find out what is U also, or E. Therefore, I have to find out 1 by T. 1 by T is equal to dou S by dou U, keeping N and V as constant, dou S by dou U. Therefore, 4 by 3 sigma V raised to 1 by 4 U, if I take a derivative, I will get to 3 by 4 U, 3 by 4 minus 1 is minus 1 by 4. This is my 1 by T. This is my 1 by T. Therefore, if I substitute these two, if I have P by T and in this 1 by T, I have to substitute this one. Therefore, this 4 by 3 sigma and this 4 by 3 sigma will cancel. I have this V raised to 1 by 4 is there, V raised to minus 3 by 4 is there. They get joined together, I will be getting V there. You have 1 raised to 3 by 4 and U raised to 3 minus 1 by 4 is there. If they are joined together, I will be getting U. And finally, you have this 3 by 4 and 1 by 4 is there, which comes to the left hand side, I will get 1 by 3, and finally, I will be able to get P is equal to 1 by 3 U by V. After substitution, I will get P is equal to 1 by 3 U by V. Therefore, these are the simple examples that I had given to you in the case of the applications of thermodynamics or finding the thermodynamics for a microcanonical ensemble. That is, from entropy, the equation for entropy S is equal to k log omega. You can use your first law of thermodynamics, TdS is equal to d plus p dv minus mu dn, and then take the partial derivatives, and from the partial derivatives you will be able to find out all the thermodynamics. Okay. And then how to find omega, we will deal with that in the next section. Okay. Thank you.